Namaste, welcome to Knowledge Plaza YouTube channel. It is all about mathematics. So today, as I'm before you to discuss about real numbers and their decimal expansions. Okay, shall we discuss about real numbers? The set of all rational and irrational numbers. Rational numbers and irrational numbers. The set of all rational and irrational numbers are called real numbers. Real numbers are represented by the letter capital R. Real numbers are represented by the letter capital R. The set of all rational and irrational numbers are called real numbers. Okay, and we are going to discuss about the decimal expansions of these real numbers. So to discuss about the decimal expansions of the real numbers, we must have to take some examples for the decimal expansions of the given numbers. Let me have some examples. 10 by 3. What will be the decimal expansion of this number 10 by 3? It is 3.33 and so on. So it can be written as 3.3 bar. 3 bar means why? It is the repeating block of 3. So here 3 is repeated digits. So only the repeating digit is a 3. So that's why 3.3 bar. Bar represents the repeating block of the number. Okay, and next. 7 by 8. 7 by 8. What will be the value of 7 by 8 after the division? 7 is not divisible by 8, so it must be 0.70 becomes, then 8 8s are 64 and 4 becomes 8 5s are, it is 0.85. This division process is ends. Okay, and next let me have one more example. 1.3, sorry, 1 by 3. What will be the decimal expansion of this number? It is about 0.33333 and so on. So it can be written as 0.3. Let me take one more example. 1 by 7. What will be the repeating digits of this number? What will be the decimal expansion of this number? 1 by 7. It is 0.142857 and it is continuous. These repeating digits are repeating again. Okay, so these are the decimal expansions of the real numbers for the given numbers which we have taken for the examples. Okay, so observe the first decimal expansion. Here the block is repeat and the number is repeats. Okay, here the digits after the decimal points are finite. It is end, the division process ends and the remainder is 0 there. And next here the digit is continuous, repeating. Okay, and here the repeating block is repeating continuously after the division. So there is no end for the division in these decimal expansions. Okay, and the decimal expansion having finite number of digits after the decimal point is called terminating decimal expansion. Okay, the decimal expansion which is having finite number of decimal digits after the decimal point are called terminating decimal expansion. non-terminating decimal expansion. Here we have took 7 by 8. Its decimal expansion is 0.85. After the decimal point, there are only 2 digits, so it is finite. Okay, and the division process ends. So then these kind of decimal expansions are called terminating decimal expansions. Terminating decimal expansion means the number of digits after the decimal point are finite. Then the decimal expansions are called the terminating decimal expansions. Okay, and some more cases we have already taken for the examples. So which are 10 by 3. What will be the decimal expansion? It is 3.3333 and so on. So here the digits after the decimal point are repeating. Okay, so then this kind of and there is no end for the division, it continues. Okay, so then this kind of decimal expansions are called. So this type of decimal expansions are called non-terminating recurring decimal expansion. Why these are non-terminating, non-recurring decimal expansions? Because there is no end for the division process. There is no reminders. The reminders will not obtaining, and the digits after the decimal point are repeating. So that's why these are repeating and non-terminating recurring decimal expansions. Okay, now we can convert these kind of decimal expansions into P by Q form. So these kind of decimal expansions can be converted into P by Q form. Non-terminating, non-recurring decimal expansions can be converted into P by Q form, and also terminating decimal expansions can be converted into P by Q form. So let me have some examples how to convert the terminating and non-terminating recurring decimal expansions in the form of P by Q. Okay, it is very easy to convert the terminating decimal expansions into P by Q form. Okay, that is already you know that. Like examples 3.142. Convert this into P by Q. How can we convert this into P by Q? 3142 by 1000, because after the decimal point there is 3 digits. Okay, so write the whole number and divide it by 1000. It is in the form of, now it will be in the form of a P by Q form. Okay, like this we can convert the terminating decimal expansions into P by Q form. So it is very easy to convert the terminating decimal expansions into P by Q form. Okay, now let me have some examples how to convert the non-terminating recurring decimal expansions. Examples: convert 0.333 so on in the form of P by Q. So convert the 0.33 in the form of P by Q. Okay, so 0.333, it is a non-terminating recurring decimal expansions. Okay, let me take that as x. Let x is equal to 0.33. Okay, however, you may take a 3 digit or you may take 4 digits. It is like to you. Call that as equation 1. And next, how many digits are repeated here? Only 1 digit is repeating, that is 3 only. So multiply the equation 1 by 10. multiply the equation 1 by 10 because the repeating digit is only 1. So 10x is equal to, it becomes 3.33. So on, call that as equation 2. Now subtract equation 1 and 2. Subtract equation 1 and 2. What we have? 10x minus x is equal to 3.333 minus 0.333. Why? Here we have to subtract the LHS side L to the LHS side and RHS side to the RHS side of equation 1 and 2. So 10x minus x is 9x and 3.333 minus 0.333, it is 3 only. Now it becomes x is equal to 3 by 9. 3 by 9 means 1 by 3. So x is equal to, what is there? X 0.333. It can be converted into 1 by 3. So it is the conversion of non-terminating recurring decimal expansion in the form of p by q. Okay, it is one of the example. And next, let me take one more example to convert the non-terminating recurring decimal expansions into p by q form. Convert 0.235 repeating block, that is into a form of p by q, p by q. So how can we convert this into p by q form? Same procedure that we have followed the last one. Let me take the given decimal expansion as x is equal to 0.235. Call that as, if you want to write one more time you can write, or it is enough. Call it as equation 1. How many digits are repeated here? 3 digits are repeating. 2, 3, 5. So 3 digits are repeating. So multiply the equation 1 by 1000. Multiply the equation 1 by 1000. What will getting? 1000x is equal to 235.235. Why? You can also write this one more time. Call it as equation 2. Because the repeating digits are repeated, no? So that's why we have taken here 2.235.235. The point is taken to this point. So after that, also the digits are there. So that's why 235.235 we are taken here. Now subtract equation 1 and 2. Subtract equation 1 and 2. But we have 1000x minus x is equal to 235.235 minus 0.235. You might write repeat, or you can write single block only. So 1000x minus x is 999. X is equal to 235. Okay, after the subtraction you are getting 235 only, and x is equal to 235 by 999. So x is converted into p by q form. Like this way we can convert the non-terminating recurring decimals into p by q form. Okay, have you got the idea? If you have any doubts, you may share your doubts in comment box. Okay, please subscribe and share more. Thank you.